Hi, Todd Dunn here, aboard my 1936 wooden powerboat Tortuga. It's 2:30 on September 17, 2018. Today I'd like to talk about my Victron 7515 SmartSolar MPPT charge controller. And what I want to do is talk about how it actually works. So, how does it work? Well, it works very well, but that's not what I want to address today. What I'd like to talk about today is just exactly how does the algorithm work. Right now, all my electrical systems have been shut down since early this morning, and the batteries are pretty much fully charged. So I expect that the charge controller is going to be in float mode. So let's take a look at it. I'm going to get my phone out and sync it to the charge controller by Bluetooth, which is built into this charge controller, one of the big positives for it, so we can see exactly what's going on right now. As you can see, it's moderately sunny. We've got some clouds that are going by, so the amount of sun hitting my solar panels, which are on the cabin top and completely unobstructed, is going to vary a little bit as clouds come and go. So let's get the phone out and see exactly what's going on. Here's the display on the phone. As you can see right now, it's putting out 5 watts. The panels are operating at 41.7.8 volts, putting out 1/10 of an amp, and keeping the batteries at 13.62 to 63, which is the float voltage, and it is in float mode. So what does that mean? What's going on? The purpose of this charge controller is to charge the batteries. This charge controller has 3 modes. The first mode is bulk mode, in which the controller puts as much current as possible into the batteries and pushes the battery voltage up until it reaches the bulk charging voltage, which on my controller is set to 14.3 volts. When it gets there, it goes into what's called absorption mode. In absorption mode, the current gradually trails off as the batteries get closer and closer to full charge, and when they finally achieve essentially full charge, the controller goes into what's called float mode, where it provides enough current to maintain the batteries at float voltage, which is 13.6 for my system. Of course, there are a number of different ways that this can be done. An MPPT charge controller, where MPPT stands for Maximum Power Point Tracking, in theory is going to adjust the operating voltage of the solar panels to get the maximum amount of power out of the system. But what happens when you get into float mode, where you don't need very much power to maintain the batteries at float voltage? Well, there are a couple ways it can be done. The controller could shunt some of the power that's coming in from the solar panels into a heat sink and just dissipate the excess energy as heat, or it can adjust the solar panel operating voltage to minimize the power that's coming in and get it to just enough to maintain the batteries at float voltage. The latter is what the Victron controller does. So let's take a look at the phone again and see what's going on in float voltage with this controller. Okay, you can see right now that the panel is putting out 5 watts, but my 2 series connected 12 volt panels are operating at 41.3 to 41.4 volts. That is way up at the high end of their voltage range, and when you get up to the high end of a solar panel's voltage range, the current that it can put out goes way down, and consequently the power that it can put out goes way down. So what this Victron controller is doing is pushing the panel voltage up so that only the amount of power needed to maintain the 13.6 volt float voltage for the batteries is being put out. And the panels simply aren't generating any more than that. So there's no necessity to dissipate excess power as heat. But what happens when you turn a load on? Well, I'm going to go down below now and I'm going to turn on a couple of things and we'll see what happens. Okay, I've gone down below and I've turned my refrigeration on, which is drawing power from the batteries. And the MPPT charge controller has responded to that by changing the operating voltage of the panels down to about 32 to 33 volts. And we've gone from 5 watts to nearly, well, to 40 watts. And the system is now putting out power in response to the load. Now we're up to 52 watts. The sun is getting a little bit brighter. And it will continue to do this until the load goes off. It will put out as much power as it can in response to a load. You'll also notice, if you look at the voltage there, it is changing fairly quickly. It's jumping around. That's in response to slight changes in the sun, and that is indicating that this controller has a very fast MPPT algorithm. It's changing about twice a second. Okay, so these two quick observations illustrate how this charge controller works. Basically, what it does is it adjusts the panel operating voltage to put out the required amount of power. When very little power is needed, instead of dumping excess power from, say, a solar panel in full sun to a heatsink and heating up whatever space the controller is in, it simply changes the operating voltage of the panels to the point where only the required amount of power, for example, for float stage, is being produced, and doesn't jump any excess heat into the enclosed spaces of, in this case, a boat. And I'm really pleased with the way this works. I didn't understand it from having read their information, but it's a very sophisticated algorithm, and particularly on days like, say, yesterday when it was over 80 degrees in the boat, I didn't want the charge controller to be dumping excess heat into the boat. It was plenty warm enough as it was. Of course, there are times when it would be nice, but it isn't going to happen. So anyway, it's a sophisticated, fast algorithm that simply changes the operating voltage of the panels to put out the amount of power that's needed. So I hope this has illustrated a little bit about how this particular charge controller works, and that it does have quite a sophisticated MPPT algorithm. It isn't just a simple one that maximizes the power coming out of your solar panels. It optimizes the power to what is needed. Okay, thanks for watching. If you feel like you learned something from this, give me a thumbs up. And if you haven't, please subscribe to my channel. I'd love to have more subscribers. Tell your friends about me, whatever. And if you want to make a comment, please do. I will respond. And basically, thanks again for watching.